So the first thing that we want to do on this situation is add the 10/3 to both sides to start working towards getting the j by itself. So, since we start with negative 1/3 equals j over 4 minus 10/3, we are then going to add the 10/3 so that these cancel each other out. The denominators are the same already, so we're good there. Negative 1 plus a 10 gives me a positive 9 over 3. Now, we can go ahead and simplify that, because this is not really a fraction. It's really division. I mean, it is a fraction, but a fraction is division. So 9/3 I'm going to go ahead and simplify as 3 is equal to j divided by 4. How do we undo a division by 4? Well, we multiply. So we are going to multiply by 4 on both sides. And we would get that j is... So for the person who sent me this, please make sure that makes sense, or let's chat about the process again. But we always say leave the multiplication or division to be the last thing that we do. So we deal with the addition or subtraction first by using inverse operations. These cancel out. I do the addition over here. And then I undo the division by doing multiplication. If we want, we could put the 4 over the 1 to remind ourselves 4 on top and bottom. Doesn't really make a difference. We got a couple people in the Zoom now, so if you've got a question, just start your screen share and I will take a snapshot of it, and then we can put it on my little help document. Ooh, that's a rough one. Alright, so again, I'm going to start by copying this out onto my paper, like the whole thing. I do not do any, I don't skip any steps. So, 7/8 m uh, 9/10. I'm going to leave some space as I copy this too, because I might think about denominators and things like that. Alright. So, I've got two m values, so it'd be better to write those next to each other. 7/8 m and a negative 2m or a minus 2m, however you want to talk about it. And then we have a positive 9/10 and a negative 3/5, but I'm going to go ahead and think about, well, if the 3/5 and the 9/10 are going to try to work together, we should probably establish common denominator. And I can turn 5 into 10 by just multiplying by 2. So, make sure you bring the sign with it. It's actually a negative. So I'm going to go ahead and just write plus a negative for this one. I'm going to color code this part. I mean, like I color code everything. But the m values, I'm going to say, well, if I had a negative 2... and then I added 7/8, the negative is still going to win, and it still has 1 and 1/8 left. If I can't think about that in my head, I could put the 2 over 1, and then get to common denominators by doing the times 8 on top and bottom. So if we want to write that out, it would be 7/8 m minus 16/8 m. That gives me a negative 9/8 m, which is that 1 and 1/8 that I commented about a second ago. Then, sorry, trying not to cover up any of the original problem. I go back and get my constants. And since they have common denominators now, 9/10 and a negative 6/10, so they're going to fight with each other, but the positive is going to win. And get a positive 3/10. Now, as I look around the room, guys, if you are working in Khan Academy, you should have paper and pencil out. So anytime that you're doing math, you should have out something to write on. Even if your work doesn't end up like super clean, there's a lot of times when I'm doing stuff at home when like I might write things sideways. I might not like put things perfectly stacked vertically. I get that, but you need to be able to write stuff down. All right, I got nobody screen sharing in the Zoom right now, so if anyone's got a question. Got it. All right, so again, they ask us to isolate the variable, or they say solve, but it means isolate. So I'm going to copy down the original. So if you have yet to do that, again, you don't need to be working with me. This is for anyone who wants like an extra scoop of help. (4/3) equal to -6. It's not over anything. -6e. So that's multiplication. And then minus 5/3. So remember, our task, our goal, our mission, or whatever you want to say, is get e by itself. We're working up the PEMDAS ladder. So we should always be thinking, okay, ignore whatever's like directly attached to the e for a minute and look at whatever's added or subtracted out here. So my -5/3 is what I need to deal with first. What's the inverse operation to subtraction? Addition, or a positive that will cancel out the negative, right? So I could write this up to the side right here, but either way, I write it in red to know that is something that I'm doing on both sides. My denominators already match, so that's great. We get 9/3 equals -6e. Apparently, whatever Khan Academy programmer was writing these problems liked getting to the 9/3, because here we see that again. So we know that can simplify to actually 3, because 9 divided by 3 is 3. So if 3 equals -6 times e, and this is why I like to show the multiplication, it kind of clues in my brain of, well, if we're multiplying and I want to undo that, well, then I just divide. This creates our favorite reference back to CPM, right? The giant one. So really, I think about 3/6 reduces to a 1/2, and we have to make sure we bring the negative. I like putting the negative in front or on top, as opposed to on bottom. It's not very good to keep the negative in the bottom of a fraction. It's just not very nice. All right, we picked up a new person in the Zoom, but if you want to share your screen to request a problem, please do so. Apparently my camera wants to keep focusing over and over again, so there we go. Any of you guys in the Zoom want me to do any problems? I mean, I like it if you're trying it on your own. That's good. Pretty awesome.
I know that because you came in during lunch and told Mr. that he has
Oh, nice. Yeah, there's parts of the building over there that have no roof right now, so there's a lot more space. All right, Gabrielle is building a brick wall. Each row of bricks is 6.5 centimeters tall. Wow, this is so poignant because we literally have been building brick walls down at that place I was just showing you guys. The top row, though, is 1 centimeter shorter because there is no mortar. So when they talk about each row of bricks is 6.5 inches tall, guys, every row of bricks, when you lay bricks, also then counts the mortar above it, but not above and beneath it, because think about it. If I'm laying bricks, I measure from the bottom of one brick up, and then through the mortar, and I hit the bottom of the next brick. So it's always from the bottom up to the bottom of the next one, right? So, or from like top to top. But at the very top layer, there's no mortar in between the mortar and normally there's like a sill plate or something up there. So she wants the wall to be 259 centimeters tall. So what we really know is there's a bunch of rows of 6.5. And then there's a row that is different. What would that different row be? Well, 1 centimeter shorter. Oh, if I'm recording this, I have to do this on paper. Keep forgetting what I write on the screen doesn't show up. So, what we know is we have 6.5 for, sorry, I looked over at my screen and that looks really weird now. 6.5 for every row of bricks we lay. Plus, the top row would be 5.5. Right, because they said it's 1 centimeter shorter. And that will equal the whole height of the wall. So now we use inverse operations. Forget about the thing directly attached to the variable for right now and deal with the addition or subtraction. Trying to line up decimal places over here to be appropriate. Uh, 54, 53 and a half. Then, how we undo this multiplication is by doing division. Now that you would need a calculator for. But it actually did not ask us to solve. It asked us which of these would make sense. So when I think about this equation related to what they have written, 6.5 times r times 6 negatives. That would be a negative 6.5 when I distribute. I don't think I want a negative 6.5. Now, I don't think A works. 6.5, well, the top row doesn't take 1 off of the, no, I don't think that works. Go back. Go back. Was there an option E? This problem might be broken. I mean, so you guys are smarter than I am. Does anyone see a choice here that is the appropriate choice? So the issue is every time we have 6.5r minus 1, if we do the distribution, that becomes a negative 6.5. Right. So, where I think I'm getting stuck is my brain is trying to set it up to solve, and they just want us to set it up, and that's where I'm getting screwed up. You can try B if that's what Miriam thinks it is. So, this makes sense that this makes the wall 1 centimeter. Oh, okay. So this, you're right, it is B. This is saying the wall will be the height of, I got it now. Let me explain this because now I feel silly. This is hard, guys. Math is hard. The height of the wall is what we're talking about, right? So if we set up like height equals, I'm going to end up covering that up at the end, but the height of the wall is 6.5 times the number of rows that we use. But the top row takes away 1 centimeter. So the top row is still going to be counted in the R. How I set this up here, my R would be every row but the top row, because I put the top row in separately. So they, instead of doing this, say, well, the top row will just take 1 away from the total height of the wall, and the total height of the wall is 259. So now I can cover up the H equals and do this. And that will tell me the total number of rows, which is probably actually better. This is just how my brain works, which, like, this is also why I don't like multiple choice, really, because, like, how my brain works, I couldn't quite figure out which of those made sense, but I could have solved it just in a different way, right? Like, so, yeah, this math is hard, guys. I'm not, like, just saying that because I'm, like, I teach middle school, but no, math is hard. Like, even me, your teacher, I don't always just know what the answer is. Yeah. Oh, I don't care. Yeah, do whatever. If you want to move, I got a power strip right here, too, so you can move to either of those desks. So if you want the fancy green desk. Yeah. I can go ahead and print you the... Well, I'm just going to show this to you because I want to send the notes to the actual, like, copy center, so I don't just keep running them here. So, what we're going to go over next week in our notes... For anyone who starts doing the inequality work, so check that screen right there.
And more than, and then the more than is
So, yeah, the tricky parts are knowing when to use the or equal to symbol. And I'm still recording this, so you'll be able to go access this in the YouTube video if you want, and I'll print this and give it to you guys next week. And it's not due till next Friday, so it's okay if you struggle on it at first. But the trap door in solving inequalities, if I go to the back of the notes, and now I feel like I hid this on the back of the notes because I didn't want you to see it as soon as we started the lesson, but since some of you are working on that practice already, we might as well talk about it. The direction of the inequality will flip, quote unquote, like switch directions, when there is a multiplication or division, but remember, division's the same thing as multiplication, that happens with a negative. So, because, and I've got 2 different examples here, if the value with the x is negative, like, we have a negative x there, but that's really negative 1x, right? So really we can say that's a negative 1 times x. What we have to do to get the negative x into a positive x is multiply by negative 1 on both sides. So when we do this next week, we're going to highlight this multiplication by negative 1 because this is a little messed up. They should have also shown that multiplication by negative 1 over here. They forgot to write it on this side, so we're going to write that together when we do that. They show it correctly down here in the next step. They don't show it correctly up here. Yeah. Mm-hmm. Yeah. So, what I may actually do when I go to print these notes, and Jocelyn, this is why I don't want to print it for you yet, I kind of want to cover this up because negative x is negative 1 times x. So that's another way we can think about that. I'm still deciding exactly how to print these. But the short answer to what you're asking is if you multiply or divide by a negative, you got to flip direction. And technically that's been happening in our equations, but when the equal sign flips directions, it's still an equal sign, right? So that's why we don't notice it happening for the equals, is because it changes direction, but doesn't, really. All right, I got people in Zoom, but nobody's screen sharing, and I'm ready when you are. We got like 15 more minutes. 20 more minutes, actually. Ooh, this one's a toughie. Oh, that's math too. Now, this is one where when we looked at it during class and we talked about there is the not the trapdoor, there is the shortcut option of we could divide by 7 and then not have to do the multiplication by 7, but that's not better. It is not better. It's actually worse because it makes a bunch of fractions. So what we want to do is do that distribution, and that is actually really conveniently going to make this fraction nicer. Because when we do the distribution, we get 7y, and the negative 9/7 times a 7 actually wipes out that denominator of 7. Right? So when you multiply by the same thing that you're dividing by, we end up with just the 9. So you can either say minus 9, or you can think of it as a negative. But either way, that's equal to negative 3. So now we use inverse operations to solve. 56. And now what we have is multiplication that we need to undo. To undo multiplication, we divide. Y is equal to 6/7. Do not try to write that as a decimal because it's gross. It's bad. Not a good decimal. Sure, you can actually like boot out the other person who's sharing. That's the interesting setting. All right, this goes to recycling now. We did this problem in class, just by the way. I think it was at the bottom left of one of our notes pages. I'm like, that could be totally wrong. I just, for some reason, I'm thinking that's what it was. I only remember it because Sam is the name of one of Mrs. Goldring's sons, so I was thinking about Sam buying apples. So, we are buying 3 pounds of apples, right? So whatever a pound of apple costs, that's what is going to be multiplied by 3. But the price, P for price, not P for pounds, right? P for price. It's price per pound, but this is going to be the price, has gone up. So the old price gets added by 0.75. So what we're actually going to pay is whatever the price was plus 0.75. And we're going to do that 3 times over, right? So we will pay 3 of what the price was, and we'll pay 3 of the extra 75 cents. So that is like writing out that distribution. We can get rid of the extra amount that we paid I still had to pay it, but if I just think about, man, what would I have paid back when apples were normal priced? 3, my decimal doesn't go there. 3, 6. So yeah, apples would have been $3.63 on the normal for 3 pounds. But then, oh wait, I don't want just 3 pounds of price. I want 1 pound of price. So to go from 3 pounds to 1 pound. So remember, 3 is the amount of pounds. P is going to be our price. We talked yesterday about how the units of these two values are going to be different. So even though it's like dollar, like this is dollars, this is pounds, this is dollars. So that's where we have to be careful. 121. I'm not sure what the normal price per pound of apples is, but can anyone guess why prices on like fruits and vegetables would change? What determines that? What determines that? Yeah, somebody said it. The seasons. Yeah, it's whether or not it's in season. So if a fruit or a vegetable is out of season, they can still grow it, but probably potentially like in a warehouse somewhere, or like so they put the price up because there's less of them. Yeah, or like in a greenhouse. Like in Ohio, we're not growing corn right now, but when we're growing corn, there's tons of it. Literally tons of it. There's probably tons of tons, actually, if we want to. Oh, yeah. I mean, if you think about how close the stalks are, that'd be an interesting math problem, though. Like, how many ears of corn does Ohio produce? That'd be a huge number.
And then there's more corn than people, and more deer than corn.
I don't know if there's more deer than corn. There's a lot of deer, but there's a lot of corn. First thing I'm always going to do with a problem like this is rewrite the original on my paper. Double check that you don't drop any signs or leave anything behind. Excuse me. Ooh, not equals. So you shouldn't do math in a pen, friends. Bad idea to do math in a pen. But here I am doing math in a pen. Alright, so I copied it down. I double check my signs. I think about, well, this is either minus or negative. So really I've got a negative 3.5 here. And it's not an equation. So it's not like there's any, like, quote-unquote shortcut or whatever. So we just have to do what we have to do, and we distribute. Oh man, 4, 5.5, 6, 7. You might want to double check that in a calculator. I don't even know who I'm doing this problem for. Just when stuff shows up on my Zoom, I'm just grabbing pictures of it and solving it. 12, 13, 14, I think. And then the only other thing we can do in our simplification process is to combine like terms. So my y value here and my y value here. Crud. It would help if I would actually add them together, though. So 7 and 1.25 is 8.25. Hey, where are you guys all going? We're in here for like 8 more minutes. There's...
I didn't really understand the new stuff, so I was going to wait till you had class.
So you're just going to like chill?
Yeah.
Okay, whatever.
I can do class.
I can give you a riddle. I mean, I'm just going to say it out loud. I mean, you could teach class again. If you want to do the next problem that somebody throws at me, you can. If 3 plums are worth 2 apples, how many apples are worth 24 plums? If 3 plums are worth 2 apples, how many apples are 24 plums worth? Yeah, this one was an easy one. I owe you a piece of candy when I have candy back here at school. Professor Quantum has 10 bags of coins which all look alike. One of the bags is filled with fake coins. All the genuine coins weigh 10 grams each. All the fake coins weigh 20 grams each. Each of the 10 bags contains 20 coins. Using a scale which measures in grams, how would Quantum be able to determine which bag contains the fake coins with only one massing? It says weighing, but I know you guys know the word massing, so the word you should actually use when you go to take the weight of something is you are massing the object. Professor Quantum has 10 bags of coins which all look alike. So there's a piece of important information. One of the bags is filled with fake coins. All the genuine coins weigh 10 grams each. All the fake coins weigh 20 grams each. Each of the 10 bags has 20 coins. Oh, that's flippin' brilliant. Boy, I have the answers on the back. It's brilliant. So the issue is you only get one massing. Like you can turn the scale on and like just you get one massing. If you're about to say and then, that's a second massing. You have to explain to me how. What do you mean? You just put all 10 bags on? You can't take things. You can't change what's on the scale. You only get to put things on the scale once. You're done then. Once you have put the bag on the scale, you're done because you only get one massing. Like, it's like I've given you each the opportunity to do this, but you can only walk up to the scale once. And you can't, like, once you put stuff on it, you can't change what's on it. I'm not going to give you the answer. I will read it one more time. We have about 4 minutes left. No, I lied. We're in here till 56. I can't read a clock, guys. We have 8 minutes left. I'm just going to read it word for word. Professor Quantum has 10 bags of coins which all look alike. You know what would also be easier? If I just showed it to you guys. Yeah, but he can't tell the difference. Like, we're assuming that you can't tell that one bag, like, you're going to need a scale to do it. And he can only use the scale once. Maybe, like, the scale is set to self-destruct after you weigh something. Like, I don't know why. This is not the most efficient solution, but it's the most creative. You know what I mean? Because you could just weigh all 10 bags individually and figure out which one has the fake coins. But that's not what we're asking, right? We're saying, how could you do it with just massing one time? It's the how. You have to explain to me how you could do it. Drew? You can only do that once. Because if you change what's on the scale, that's another mass, right? Like you're going to change what the mass comes out to be. So you have 10 bags. I mean, no, again, they would just have to mass them or check the coins in some other way. Each bag has 20 coins in it. We'll give you another easier one while you think about that. What does no man want, yet no man wants to lose? I think a lot of men want money. This is definitely like a play on words sort of thing. What does no man want, but no man wants to lose? Some of your dads probably already have this, depending on how stressed you've made them. Keep thinking. I think a lot of guys want a beard. I want one, but I can't grow one. Comes in all patchy. That's pretty intense. All right, I will just tell you this one because it's not even mathematical or whatever, so you can get a bit more of a feel for mind trap. Because I hope that we have more time to do this while we're at school in person. So the question is, what does no man want, yet no man wants to lose? And the answer is a bald head. Because if you lose your head, it's like, well, one, that's a figure of speech for like flipping out, right? Or like literally it's like somebody chops off your head. So like you don't want a bald head, but you don't want to lose your head. So yeah, that's like a play on words one, right? So that's kind of how this game works, is you got to think outside the box, think creatively about what it's saying. Here's a mathy one. 2 cyclists rode their bicycles up and down a hill. They averaged 10 kilometers per hour on the way up and 20 kilometers per hour on the way down. What is the average speed for the entire trip? I love these questions. So think about what don't you know, and does that matter, / can we figure it out? There's a few things we don't know here, actually. We could like kind of make them up. So I don't think you'll have enough time to finish this, but if I help you think through it. Do you know how long the hill is? Like, do they tell you a distance? We don't know how long the hill is. And we don't know how long it takes. You're on the right track, but if we take, you're saying take a coin from each bag, we're going to have to mass like multiple times, right? How about this? Come back to me later after you think it through. Like after you take some more time with it. You're on the right path. But you need to keep going down that path. Alright, I'm going to come around with wipes. I love when you guys get deep in thought about something that like you don't have to solve. Like this isn't your homework, but these are interesting problems. What's that? I can't hear you at all right now, Madeline. Give me just a second. All right, what were you saying? Will, are you still on my Zoom? I was about to say, can you just screen share real quick so I can see it and maybe take a little picture? You're not? Oh, no.